Okay, so here's the reaction that we did today. We're looking at reaction rate and how that's affected by temperature. So glow sticks, once you crack them, you've allowed two chemicals to be combined, and when the particles in these chemicals collide and hit each other, they produce a glow from them, hence glow sticks. So they release light. And so these are a really great way of just quickly visualizing reaction rates. So firstly, I've got some warm water or hot water here and cold water. And what we're going to do is we're literally going to stick them all in the hot water first, so we get them going. Some of them aren't as good as others. So if I put them in there, you'll start to notice quite instantly that the light becomes brighter. And what's going on here is that the particles get more energy as you increase the temperature. And as they have more energy, then they are hitting each other with greater force. And then that means there's more successful collisions, which then leads to the reaction occurring. For a reaction to happen, there has to be enough successful collisions between the two reactants so that the products are made. And in this reaction, we can see successful collisions as light. So they become brighter, and you can compare them to the bit at the top. Some of those are still glowing a little bit at the top. They're already instantly growing far brighter. It'd be good if I had two of the same ones, but I don't at the moment. So I might repeat it at a later date with some better glow sticks, but this is working, you can see that. So they're all glowing. In fact, even the ones that weren't glowing before are starting to glow now. Much brighter, faster reaction. Okay, when I was a kid, when we get glow sticks, loved them, they were awesome, but they're so rare, we didn't get them very often. So when we got them, we would often put them in the freezer to save them for longer. I mean, ultimately, we would also forget them in there. So here we go, we've put them in cold, icy water. You can see the ice in there, and that's going to cause a decrease in the temperature. And as a decrease in the temperature means those particles are going to slow down. And as the particles slow down, then they're less likely to run into each other, hit each other, collide with enough force to cause the reaction to happen, to form the product. You can even see them, they've pretty much turned them off this way. That's how cold it is in there. It's probably about 4 degrees here, and this one's maybe 60 degrees. It's roughly where water gets to after being out for a little bit once boiled. You can see I've pretty much turned them off. I haven't turned them off, I've just slowed the reaction so much that you really can't see the reaction occur. You can't see the light being produced. You can at the ends, that is still quite warm, but the bits that I stuck in the cold water are not reacting as much. Even with this one, it's nice, I can bend it. You can see the side that was put in the cold water maybe needs more. Maybe we'll put some more cold water and see if we can get a change in that reaction there too. Okay, so yeah, most of these have kind of gone out because they have been, well, they're too cold. And again, just put them back in the hot water, and the particles will heat up, they'll move faster, they'll hit each other, and they'll produce light. And hit each other and react, sorry, I should clarify reaction in there, and they will produce more light. And that is the basics of this demonstration. But it's really important, it's not just that they won't glow as much, it's that there's a reaction going on here that's making the glow. Now, we stored them in the cold environment because we wanted them to last for longer, but of course when they last longer they don't glow nearly as much. And I wish I'd remembered that they were in there, because then I could get them out and stick them in warm water and make them glow better again. Anyway, that's our fun chemistry for today.